So I am saying all PCs are connected with one switch, and by default all ports of switch belongs to single VLAN, that is VLAN 1. By default all ports of switch belongs to VLAN 1. So that is the reason why these all user can communicate with each other. Guys, whenever we are saying that, let me
PM, PC2 and PC3 have the same IP address.
no, have different IP address from the same network.
It's 10.112, 10.112.
Oh, here it is 10.113. 10.113. Okay.
Okay.
And these all interfaces are in single VLAN, that is VLAN 1. That is VLAN 1. By default on switch, if you will check VLAN, so there are some by default VLAN. VLAN 1, after that VLAN 1002, 1003, 1004, and 1005. These are by default VLAN on switches. How many VLAN are there by default? 1, 2, 3, 4, 5. 5 VLANs are there by default. If you are purchasing a new switches from the market, then there will be 5 VLAN on the switch, and by default all interfaces will be the member of VLAN 1. Getting my point? Guys, one VLAN means one broadcast domain. One VLAN means one broadcast domain. Two VLAN means two broadcast domain. VLAN means three broadcast domain. So by default on this switch, how many broadcast domain are there? Only one, because only one VLAN exists on this switch. Getting my point? What I am saying? I am saying one VLAN means one broadcast domain. One VLAN means
You
one.
stop screen sharing.
No.
Yeah, we can see your screen.
Oh. Is it fine now?
Yes.
So I am saying one broadcast domain means one VLAN means one broadcast domain. Broadcast domain. So all the user who belongs to same broadcast domain can communicate with each other. So by default all PCs, PC1 to PC4 belongs to same broadcast domain. So that is the reason why these user can communicate with each other. Okay. Two VLAN means two VLAN means two broadcast domain. Cast domain. Here also say domain. One VLAN means one broadcast domain, two VLAN means two broadcast domain. So by default on this switch there is only one broadcast domain. If you want to verify, here I have console of my real devices. First of all, on this switch I am going to run command so VLAN brief. This is the command to check VLAN database. This is the command to check VLAN database. If I will check VLAN database, you can see on this particular switch there are some VLAN. First is VLAN 1, that is default. Here you can see the keyword default. After that we have these VLAN. So these VLAN are reserved VLAN. We are not going to understand or learn these VLAN. Okay, we don't need to do anything with these VLAN. These are by default, and purpose of this VLAN is different. This is not our concern. Our concern is, you can see there is only one VLAN, that is default VLAN, and all interfaces of this switch belongs to this VLAN, like 0/1, 0/2, 3, 4, 5, 6, 7, 8, 9, 10, 224, and G0/1, G0/2. All interfaces are in which VLAN? VLAN 1. Yes or no? Is it okay?
Yes.
The second way to identify the VLAN is we can check again show MAC address table. So MAC address table. You can see there is, these are the MAC addresses of PC. Machine have learned MAC address of all PC on interfaces and in which VLAN? In VLAN 1. This is information of VLAN. Or it is better if I will use keyword dynamic here to filter the output. Now you can see. Switch have learned all MAC addresses of PC on which port? On this port and in which VLAN? In VLAN 1. Getting my point? Is it clear?
Yes.
And here we are able to see one more thing. Total MAC addresses for this criteria is 5. That means this switch have learned 5 MAC addresses. And if I want to see how many VLAN are there, I can run command show VLAN summary. This command will show me how many VLAN exist on this particular switch. So how many VLAN exist, guys? 5. VLAN 1, VLAN 1002, 1003, 1004 and 1005. So there are 5 VLAN exist on this particular switch. And now I am going to do one thing. First of all, I am going to down all interface of this switch, and then I will run no shut on 0/1, 2, 3 and 4 only, because I am going to use only these 4 ports. So interface range F1/0/1 to 24. I am going to say shutdown down to all interfaces, and after that once all interface will goes down, I will up only 4 interfaces 0/1 to 0/4. Interface range F1/0/1 to 4 and say no shut. No shut. This port will come up. Okay, see the log message. Fine. How to verify directly connected devices? So CDP neighbor, because in real time you cannot see, right, the topology. So you have to check the on which interfaces devices are connected. So I can run this command show CDP neighbor. In show CDP neighbor, we are able to see PC1 is connected on 0/1 port, PC2 is connected on 0/2 port, PC3 is connected on 0/3 port, and PC4 is connected on 0/4 port. Fine. And guys, in real time we are not using this command as well for the security purpose, because CDP is a protocol which is not secure. So the second way to find the connected device, you can use show interface status. So interfaces status, this command. In this command we can see few ports are disabled and few ports are connected. Done. 4 ports are connected. If you want to filter the output, here also you can filter the output. Here we can say include connected. Just I want to show only connected port, so it will show you only connected port. Okay.
Yes.
Fine. Now a single port can be if you are running command show interface status, that port can be connected, that port can be disabled, or that port can be down. That port can be down. See, this interface 0/1 is connected with PC1. I am going to down PC1 interface, PC1, and then go to interface F0/0 and say shutdown. I have done this interface, and now on PC on switch I am going to run again command show interface status. So this time you can see it's saying this port is not connected. So this is the third type of output. First, port can be connected, port can be disabled, or port can be not connected. Disable means port is shut down. If line protocol means never device is down, then port will show you not connected. Done. Again I am going to run no shut command here, and interface F0/1 says shutdown. PC2 also F0/1. I am not going to use this interface, so let me shut down the port. I am going to configure IP address on all PC. First, I am going to configure IP address on all PC. Let's begin from PC number 1. PC1 interface F0/0 IP address 10.1.1.1 255.255.255.0. PC2 interface F0/0 IP address is 10.1.1.2 255.255.255.0. Go to PC3 interface F0/0 IP address is 10.1.1.3 255.255.255.0, and then PC4 interface F0/0 and IP address is 10.1.1.4 255.255.255.0. Done. PC1, PC2, PC3 and PC4. All PCs have IP address. If you want to verify how I will verify, so IP interface brief exclude unassigned. You can see fast Ethernet 0/0 IP address is 10.1.1.1 on PC number 1. On PC number 2 also, so IP interface brief exclude unassigned. We can see IP address is 10.1.1.2 is the IP address of PC2, PC3, so IP interface brief exclude unassigned. IP address is 10.1.1.3, that's fine, and on PC number 4, so IP interface brief exclude unassigned. IP address is 10.1.1.4. And now I am going to ping from PC1 to PC2. What is the IP address of PC2? 10.1.1.2. Yes or no? So PC1 is able to ping PC2. Yes or no? You can see. PC1 is able to ping PC2. PC1 is able to ping PC3 also. Right? And PC1 is able to ping PC4 also. That means all PCs are able to communicate with each other. Now guys, I want to stop communication between some computers. Let's say, as I told you last time, that these two computers belongs to different VLAN. VLAN 10. Here I cannot use transparent, so let me then delete it. Okay, let me use pen. See, these two interface should able to communicate with each other. These two interfaces should able to communicate with each other. That means PC1 can ping to PC2, PC3 can ping to PC4, and PC4 can ping to PC3, PC2 can ping to PC1. But PC1 and PC2 cannot communicate with PC3 and PC4, and PC3 and PC4 cannot communicate with PC1 and PC2. Getting my point what I am saying?
Yes.
So what I will do, I will put these two interface in different VLAN, let's say VLAN 10, and I will put these two interface in different VLAN, that is VLAN 20. Okay, see how I will achieve this task. On switch, first I will create two number of VLAN. I will create two VLAN 10, and after that we can define the name. Let's say name is sales and exit. After that VLAN 20, name is, let's say, a content and exit. I have created two VLAN. How I can verify? By running command. So VLAN, if you will run summary command, then you can see total number of VLAN is 7. And if you will run show VLAN brief command to check VLAN database, you can see there is two more VLAN 10 and VLAN 20. Okay. Okay. Is it okay?
Yes.
For everyone? Just I have created two VLAN. But now in VLAN 10 there is no any interfaces, and in VLAN 20 also there is no any interfaces. So I am going to put some interface in VLAN 20 and some interface in VLAN 10. Go to interface range f1/0/122. These two interface should be in which VLAN? In VLAN 10.
VLAN 10.
So switch port access VLAN 10. That's it. After that, interface range f1/0/3 to 4. These two interfaces should be in which VLAN?
20.
Switch port access VLAN 20. And now here if you will check show VLAN brief, you can see in VLAN 10 I have two number of interfaces, right? VLAN 10 have two interfaces and VLAN 20 have two interfaces. Now these two interface can communicate with each other and these two interface can communicate with each other, but inter VLAN devices cannot communicate with each other. Let me verify. From PC1 again I am going to ping which computer? PC2 10.1.1.2. I'm able to ping PC2, ping 10.1.1.3. I'm going to ping PC3. See, ping will not work. So who is dropping the traffic? Switch is dropping the traffic. Why? Because when this PC will ping to PC number 3, source IP will be 10.1.1.1, destination IP will be 10.1.1.3. After that, source MAC will be the MAC address of PC1, let's say 0A, MAC address of this PC 0A, MAC address of this PC 0B, MAC address of this PC 0C and 0D. And destination MAC will be 0C. So yeah, this PC will forward this frame to switch. Switch will receive this frame on this port 0/1 port, and it will check destination is what 0C. It will find MAC address table for VLAN 10 only. You know how switch is going to run the command. It will not check entire MAC address table. It will check MAC address table for VLAN 10 only. So MAC address table. After that, you can see I can define VLAN. So VLAN 10. It will check MAC address table like this and then dynamic. So MAC address table dynamic. After that VLAN 10. In this table, are you able to see MAC address of PC3? No. No, we are not able to see MAC address of PC3. So switch will simply drop the traffic. Earlier switch was checking MAC address table like this. So MAC address table dynamic. Right? Now switch will check MAC address table with VLAN. You can see this interface F0/1 is in VLAN 10 and it need to forward traffic from 0/3 interface, because on this interface switch PC3 is connected, but this interface belongs to different VLAN. So switch will not pass any traffic of VLAN 10 to VLAN 20. So that's why PC1 is not able to ping PC3. And in the same way PC1 cannot ping PC4 also. But PC3 can ping to PC4. These two PC3 and PC4 can communicate with each other. See, right, ping is working, but PC3 cannot ping PC2 and PC1. See, ping is not working. So is VLAN concept clear,
Yes.
everyone?
Yes, clear.
Very good.
Yes.
Okay, great. Now let's say my scenario is little bit different. In my scenario, I have switch 1 here. Let me design another topology. And after that, I will design that topology in rack also. This time I have two switch. Switch 1 and switch 2. And again I have some computer, let's say 2 computer here and 2 computer here. switch 1, switch 2, PC1, PC2, PC3 and PC4. Okay, now let's say this interface is in VLAN 10. This is 0/0, 0/1 of switch 1. This is 0/2 of switch 1. This is 0/3 of switch 2, and this is 0/4 of switch 4. Done. Now let's suppose this interface is in VLAN 10. This is in VLAN 10. This interface is in VLAN 20. Again, this interface is in VLAN 10. And this interface is in VLAN 20. VLAN 20. Guys, between switch 1 and switch 2, how many link I need to use? See, if I am connecting one link, by default, this port, this is 0/19. This port is 0/19. Here also, this
And
is
I have a
0/.
question, sir. Right
Yes.
here, like PC1 and PC3, they both are in the same VLAN.
PC1 and PC3, yes, both are in same VLAN,
They
but
will
on different
ping-
switch.
But they will ping each other.
Yes, they will ping each other. Why not? Same
Okay, sir.
VLAN users should be able to ping each other.
Yeah, if a switch is different, it doesn't matter.
Doesn't matter. Doesn't matter. You have connected PC number 3, but if it is in same VLAN, then it should communicate. Let's say one user is in India and one user is in America, US, and if both are in same VLAN, they should able to communicate with each other. Okay, and we
Yes,
have
yes.
connectivity through internet. Doesn't matter. Same VLAN user should be able to communicate with each other. Okay, here our concern is different. See, by default this port 0/19 is member of which VLAN, guys?
VLAN 10.
VLAN 1 by default.
No, VLAN 1, okay.
By
By
default, all interfaces are member of VLAN 1. So that means this interface can carry traffic of VLAN 1 only. That means this VLAN can carry traffic of VLAN 1 only. See, this port, now this port can carry traffic of VLAN 10 only. This port can carry traffic of VLAN 20 only. This port can carry traffic of VLAN 10 only. And this port can carry traffic of VLAN 20 only. So in the same way, if this interface is in VLAN 1, so this interface will carry traffic of VLAN 1 only. Getting my point?
Yes.
So I have to put this interface in which VLAN? In VLAN 20. Sorry, 10. So that it can carry traffic of VLAN 10. Yes or no?
Yes.
After that, this port should be also in VLAN 10. Then only it can carry traffic of VLAN 10. And I have to use one more link between switch 1 and switch 2 for VLAN 20. Yes or no?
Yes.
Now VLAN 10 user can communicate with each other, but VLAN 20 user cannot communicate, right? PC2 cannot ping to PC4. Getting my point? So I have to use one more link here. And let's say this port is 0/20. This port is also 0/20. And 0/20, I will put 0/20 port on both switch in which VLAN?
VLAN 20.
In VLAN 20. Now VLAN 10 user can communicate with VLAN 20 user, because upper link will carry traffic of VLAN 10 and lower link will carry traffic of VLAN 20. So I will put this interface in VLAN.
What I mean,
20.
one link cannot forward traffic from two
Yes,
different
that
VLANs.
is the concern, that how one link will carry traffic of multiple VLAN. Because
Okay.
if I have 50 number of VLAN between switch 1 and switch 2, then I have to connect how many link? 50 link.
Yeah.
So after this, we will understand how a single link can carry traffic of multiple VLAN. First of all, let me design this topology in rack. Okay, guys?
Okay.
So in rack, as I show you here, let me reduce the size of this topology. Hope it is visible, or I can do one thing.
It is visible.
It is visible?
Yeah.
Okay, then that's fine. Or I can do one thing. I can copy this diagram and I can paste this diagram in Microsoft whiteboard.
Sir, you still have recording?
Yeah, recording is on. This diagram. Okay, and see, I am going to design this diagram first in my topology. So for that, I am going to do one thing. See, PC switch 1 is connected with PC1 and PC2. That's fine. Switch 1 and switch 2 is connected with 0/19 and 20. So I am going to up interface F1/0/19. Say no set here. Interface F1/0/19. Okay, I am running this command on PC, sorry. On this switch, interface range F1/0/19 to 20. I'm going to say shutdown this port. And one more thing, PC3 and PC4 is now not connected with switch 1, so I am going to down interface range F1/0/3 to 4. I'm going to shut down this port because now PC3 and PC4 is connected with another switch, and I am going to access switch 2 also here. So let me access switch 2. Okay, and one more thing, this is PC 0/0 is connected with switch 1, PC 0/0 is connected with switch 1, and PC3 0/1 is connected with switch 2. So I am going to change on PC number 3 also. Interface F0/0, I am going to say no IP address and shut down. Exit interface F0/1, IP address is 10.1.1.3 255.255.255.0 and say no set. And I'm going to do same thing on PC number 4 also, because PC3 and PC4 is now connected with switch 2. Ten dot 1.1.4 255.255.255.0 done. Switch 2, this is my switch 2, and on switch 2 I am going to up some interfaces. Before that I will down all interface. Just I am designing the topology, guys. Here you don't need to focus much. I have done all interfaces. After that, interface range F1/0/3 to 4 and F1/0/19 to 20.
You forgot slash in between 0 and 3.
Okay, so I am going to up these 4 interfaces. 0/3 which is connected with PC3, 0/4 which is connected with PC4, and 90 and 20 this is the link between switches. Done. Say no set. And on switch number 1, if you will run now show CDP neighbor, so CDP neighbor, you can see neighbor is PC1 and PC2. Soon it will show you switch is also their neighbor. Okay, just wait. Now it's showing only PC are connected. On switch number 2, so CDP neighbor. Now you can see PC2, switch 2 is saying my neighbor is PC3, PC4 and switch 1, switch 1. Switch 1 is neighbor on 2 link, 19 and 20. On switch number 1 also, you can see, okay, it's not showing you. After some time it will show you. So CDP. After 60 seconds it will send or receive the okay CDP message. Okay, now we are able to see show CDP neighbor. PC1 is neighbor, PC2 is neighbor and switch 2 is neighbor on 2 link. Okay, and so VLAN brief. On switch number 1 I am going to check VLAN. So here VLAN 20 is not required now. Yes or no? Here VLAN 20 is not required now. Okay, VLAN 20 is required, but these two interfaces are not in VLAN 20. Only one interface is in VLAN 20. That is 0/2. So first of all, go to interface range F 1/0/3 to 4, and I am going to say no switch port access VLAN 20. Okay, and do so VLAN brief. Now you can see in VLAN 20 I don't have any interface. I'm going to put 0/2 in VLAN 20. Interface F 1/0/2 and switch port access VLAN 20. Okay, and so VLAN brief. Now you can see on switch number 1, 0/1 means PC1 is in which VLAN? Is in VLAN 10, and 0/2 means PC2 is in which VLAN? VLAN 20. In the same way on switch number 2 also I am going to configure 2 VLAN 10 exit and VLAN 20 exit. After that interface F 1/0/3 switch port access VLAN 10. This port should be in VLAN 10, and then interface F 1/0/4. This port should be in VLAN 20. Switch port access VLAN 20. Right here also we can check. So VLAN brief. You can see PC3 is in VLAN 10 and PC4 is in VLAN 20. Can PC1 ping to PC3?
Yes,
Now
yes.
it's question, guys. First of all, tell me, can PC1 ping to PC2?
No.
Ping 10.1.1.2. No, because both are in different VLAN. Can PC1 ping to PC3?
Yes.
No, because by default link between switches are in VLAN 1. See now on switch, so VLAN brief. These two ports 90 and 20. 90 and 20. These two interfaces are in which VLAN? VLAN 1.
Yeah.
So that's why PC1 cannot ping to PC3 also till now. Okay. But if I will put 0/19 in VLAN 10 interface F 1/0/19 and switch port access VLAN 10, and go to switch 2 also and interface F 1/0/19 and switch port access VLAN 10. Now can PC1 ping to PC3?
Yes.
Ping is not working. I have to check the IP. On PC number 3, let me check IP configuration. IP is fine. 10.1.1.3 IP is fine here, and on this switch, so VLAN brief. In VLAN 10 we have two interface 0/3, okay, and 0/19. That is also fine. On switch 1, everything is fine. Let me ping again. So VLAN brief. So VLAN brief. It should ping.
The port on PC1 to switch is a 0/0 on PC1. And I think you can,
PC1 is 0/0 interface. Yes, that is fine. 0/0 of PC1 is connected with switch 1.
The problem should be between two switches. Maybe-
Between two switches also link is showing fine, because so VLAN brief. On switch number 2, 0/90 is in VLAN 10, and 0/3 is also in VLAN 10. So that's fine here. And here also it look like fine. Let me do one thing. Let me configure other link between switch 1 and switch 2. Interface F 1/0/20 and switch port access VLAN 20. Switch number 2 also interface F1/0/20 and switch port access VLAN 20. Now PC2 should be able to ping PC4. Okay. Let me do one thing. Here also it is fine. Here also it is fine. Then it will not ping PC2, that is fine, but it should ping PC3. PC3. Yeah, now it's working. Ping is working. Okay, maybe because of routing was enabled on PC, because of that it was not working. But now you can see PC1 is able to ping PC3, and PC2 is able to ping PC4. Ping 10.1.1.4. PC2 should be able to ping PC4. You can see.
Yes.
Am I right?
Yes.
PC1 is able to ping PC3 and PC2 is able to ping PC4 because both are in same VLAN. But guys, what is the problem here? Problem is, let's say if I have 50 number of VLAN on switch number 1, then I need to use 50 link between switch 1 and switch 2. So this is not the efficient way. Here we have one more types of port, that is called trunk, and by default all ports of switch is called switch port, and switch port can carry traffic of, by default there are two types of switch port. If I will talk about switch port, so there are two types of switch port. Switch have two types of port. One is access port, and second one is trunk port. Access port, it can carry traffic of single VLAN, and trunk port, it can carry traffic of all VLANs. A trunk port can carry traffic of all VLAN. So instead of connecting two links between switch 1 and switch 2, I can connect one single link, that is trunk link. This link is trunk, and here also I will configure this link as trunk link. Now guys, understand one concept, very important concept. Okay, be careful. See what I am saying. Whenever PC1 will ping to PC3, let's say PC3 MAC address is 0C and PC1 MAC address is 0A. When PC1 want to ping PC3, source IP will be 10.1.1.1 and destination IP will be 10.1.1.3. Am I right?
Yes.
Source MAC will be 0A, destination MAC will be 0B. It will forward traffic to switch.
I mean 0C.
Switch will
source is 0A and destination 0C.
Destination is 0C, sorry. 0C. Switch will PC will forward this traffic to switch. Switch will receive it on this interface, and this interface is member of which VLAN? VLAN 10. So now switch will forward this frame from the port which is member of same VLAN or from the trunk link. So here on this particular switch there is no any port belongs to VLAN 10. There is no any more interface belongs to VLAN 10, but there is one trunk link. As I told you, trunk link is a part of all VLAN. So this is a part of VLAN 10 also, this is a part of VLAN 20 also. Then switch will forward this frame from this interface, yes or no?
Yes.
Because this interface is member of all VLAN. Now how switch 2 will came to know that this is a traffic of VLAN 10, yes or no? On trunk link, switch can receive traffic of multiple VLAN, but how switch 2 will came to know that this is traffic of VLAN 10 or this is a traffic of VLAN 20, yes or no?
Yes.
So because of that, whenever switch will forward any frame on trunk link, it will add one tag with frame. With frame it will add one tag, and in that tag there will be information of VLAN ID. So in tag it will add what VLAN ID? 10. And when switch 2 will receive any traffic on trunk link, first it will check tag field. In the tag value is what? 10. Oh, that means it is a traffic of VLAN 10. So I will forward this traffic from this interface because this interface is member of VLAN 10. Getting my point? On trunk link, tag is required, yes or no? Without tag, if switch 1 will forward traffic on trunk link, switch 2 cannot understand this is a traffic of which VLAN. Okay? Okay? Is it okay?
Yes. Yes.
And guys, to add tag number, actually switch will add tag automatically. That means definitely we will have one protocol. So we have two types of protocol for tagging. One is ISL and another one is .1Q. .1Q. ISL is a Cisco proprietary protocol. That means you can run this protocol only on Cisco devices, and .1Q is open standard. We can run this protocol on any devices. And nowadays Cisco is also using .1Q because there is some advantage of .1Q over ISL. This is not your concern. Your concern is only you should have knowledge that we are using .1Q nowadays. Earlier Cisco was using ISL protocol. So what is .1Q protocol or ISL protocol? It is an encapsulation protocol for tagging on the trunk link. It is an encapsulation protocol for tagging VLAN ID on the trunk link. Okay, so now I am going to remove one link between switch 1 and switch 2. Okay, like between switch 1 and switch 2, now I am using two number of link. So I am going to remove one link. Interface F1/0/20. I'm going to say this interface to shut down, and no switch port access VLAN 20 also. Okay, I have shut down port number 20. On switch number 2 also I am going to down port number 20. Interface F1/0/20, no switch port access VLAN 20, and shut down. Done. Now how many link I have? Only one. So till now can PC1 ping to PC3? Yes, because one link is there and that link is part of or member of VLAN 10. I am going to configure 0/19 in VLAN 1. Interface F1/0/19 and switch port access VLAN 10. I am going to say no to this command here. I have removed it, and from 0/19 also on switch number 2 also I am going to remove, say no switch port access VLAN 10. Now can PC1 ping to PC3? No. You can verify it. PC1 is not able to ping now PC3 because between switch 1 and switch 2 I have only one link, and that link is a part of VLAN 1. How we can verify? By running command show VLAN brief. So VLAN brief. You can see 0/19 is a part of which VLAN? VLAN 1. And on switch number 2 also show VLAN brief. 0/19 is a part of which VLAN? VLAN 1. I am going to configure now 0/19 as trunk port. Okay, so let me show you how I will configure the port as a trunk. Interface F1/0/19 and switch port mode trunk. This is the command. But if you will run this command here, it's saying command rejected. Why? An interface whose trunk encapsulation is auto cannot be configured as trunk. So first you have to configure encapsulation protocol. Encapsulation protocol, either .1Q or ISL. Because encapsulation protocol is by default auto. So and you are configuring the link as a trunk. So you are not allowed to configure trunk before configuring encapsulation protocol. So here I am going to say switch port trunk encapsulation, and after that if you will put question mark, you can see you have two options, .1Q and ISL. Let me use .1Q. .1Q. I have defined encapsulation protocol, and now I can run switch port mode trunk command here. Switch port mode trunk. In the same way on switch number 2 also I am going to configure 0/19 as a trunk. 0/19 switch port trunk encapsulation dot 1q and switch port mode trunk. That's it. If you will check how many command I have run on this particular interface, you can run command. So run interface f1/0/19. Just I have add this command, these two command. Okay. And how to verify the trunk link? By running command show interface trunk. So interface trunk. You can see show interface trunk. You can see 0/19 is configured as trunk, and which encapsulation protocol you are using, .1q, 802.1q, and a status is trunking. Native VLAN is one, that is different path. Allowed VLAN on this trunk link is VLAN 124094, means all VLAN are allowed over here. And how many VLANs are active on this switch? 1, 10 and 20. And now again you can see PC1 can ping to PC3, yes or no? Getting my point? So if you are thinking that if I have 10 number of VLAN on switch number 1 and 10 number VLAN on switch number 2, then I have to use 10 link. No guys, you will use single link and you can configure that link as a trunk. Done? Is it clear to everyone?
Yes.
In the same way, PC2 can ping to PC4 10.1.1.4. So now a single link between switch 1 and switch 2 is carrying traffic of both VLAN 10 and 20, because that link is trunk link now. Okay. So this is all about VLAN concept. Any doubt, any confusion?